So I think we can begin. Um, Welcome everyone. Thank you for joining today's meeting. Um, this is the final Living Lab workshop of project BIMERR. This is as the project coordinator Otilia Werner Kaitola will explain further, is the culmination of the work done for the last 4 years that we want to present to a broader audience. My name is Aris. I represent Merit Consulting House, which is the dissemination and communication partner of the European funded project BIMERR. Before beginning, I just want to go through 2 or 3 details. First of all, at least for the external people participating, it would be great if you could spare the time and write in the chat your job title, and if you wish, also the company or organization for which you work. It will give us an idea about the audience that joined. Of course, with the COVID restrictions, things have become a bit more complicated, but it would be great if we knew some information about you. Now, regarding questions and comments, there are 4 distinct sessions during the presentation about different BIMERR toolsets. We shall indicate the time for questions between these sessions, and of course, there will be a question and answer session at the end. Where we can address any other issue or comment that you have. The workshop is being recorded, so I have to inform you, but be sure that no sensitive information as names of participants will ever be visible or communicated whatsoever. One last thing is, unless of course it's impossible, it would be best if at least the person who speaks has the camera turned on. So with this in mind, I think we can start. Let me just okay. So thank you. I hope you enjoy the workshop and all the information that is going to be provided. And we begin with Otilia. Hello, Otilia. Good morning. It seems that we cannot hear you.
Sorry for that. So good morning, everyone. I'm Otilia Kaitola, coordinator of the BIMERR project. I would like to also from my side to welcome everybody to the final BIMERR Living Lab. BIMERR stands for Beam-Based Holistic Tools for Energy-Driven Renovation of Existing Residences. So we are a team of 16 partners working on the BIMERR project. We are 10 industrial partners and 6 partners from research institutions and universities. Before we introduce you to the BIMERR tools in more detail, I would like to present you what we call BIMERR Road or BIMERR Path. So at the beginning of this path, we have a building to be renovated for which we may have or we may have not a digital model, more specifically a BIM model. At the end of the road, we'll have a building which will have overcome an energy-driven renovation. So what BIMERR delivers is the software tools for in between, so to say, for the whole BIMERR road or path. So these are software tools, or what we call also sometimes tool bundles, along this whole path to digitalize the whole process of a building renovation, according to or with focus on energy efficiency. How do we do this? So we do this in 4 phases. So the phases we try to symbolize with the circles in green that you are seeing. Phase 1, we'll collect as is static data. So we have 3 tools for that. What we will do is to generate semi-automatically a first version of the IFC file of the building. We will, on a second step with another tool, enrich this this 1FC file, considering also mechanical, electrical, and plumbing components. And in a third, using a third tool, we will also enrich it with elements that are necessary for modeling the energy performance of the building. So at the end of this phase, we'll have the as-is static data, and we'll be going then to phase 2, which is about collecting dynamic data. So for that, BIMERR offers 2 tools, the BICA app and PRUBS, that we are going to know in much more detail afterwards. Here, what dynamic data for us means is that we are going to be collecting data that is resulting from occupant behavior when you think in terms of energy consumption. So by using the tools in this phase here, at the end of phase 2, we will we can say have captured occupant behavior regarding energy consumption by means of a wireless sensor networks that is going to be installed in the building. So at the end of this phase, we will also have got feedback automatically through a tool from the residents. So to improve the accuracy of these models and the performance of these models, which are going to be used in turn in phase 3. So phase 3, as you see, is about performing energy audit and selecting the renovation measures or renovation interventions that are going to be applied. So we have developed in the project 2 tools for that. Reno DSS and again PRUBS. So based on the static and the dynamic building data that's coming from phase 1 and phase 2, a renovation planner will be able to run simulations and also to estimate the performance of existing building, and also estimate the performance of measures or alternative scenarios, candidates, renovation scenarios, in terms of energy comfort and several other KPIs that he or she can choose himself. So what happens here is that in phase 3, the renovation planner gets all he needs to decide for a certain set of renovation interventions. So at the end of the phase 3, the renovation planner will have chosen which combination of renovation interventions should be applied to the building concerning several specific KPIs that he has chosen himself. So we are going to know much more about this tool also in another section today. Coming to the last phase, phase 4, here is about applying and monitoring renovation measures that were chosen in phase 3. So we have here a toolkit that's composed by 3 tools. We call it PWMA toolkit. So in using these tools, the renovation manager will be able to model the renovation process and to create also the work orders attached to it. So a worker can use another BIMERR tool to keep track of his or her work orders and also get support on, for example, what to do next, or also get notifications for any issues that are happening during the construction works. So also in this phase, there is a tool, a BIMERR tool that a resident can use to get notified about health and safety issues. And so this is done like he will get those notifications solely for his apartment, all what concerns that apartment. So this is the BIMERR road or BIMERR path with the 4 phases. What we are going to be doing next is to go more in detail into phase 1. And we are going to present you a bit more in detail the Scan to BIM tool, a IPFA tool, and also the BIM management platform used in the phase 1. I will give the floor then to my colleague, Fred. Sorry, Fred, you are muted.
Still muted.
We can hear you now, I think.
Yeah, now it's supposed to work,
Yeah, yeah.
right?
Yes.
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 Yeah.
I don't know why. There are some team settings sometimes that just don't get through. So thank you very much. I will now present you the Scan to BIM tool. What is the scope of the Scan to BIM tool? Is to provide a semi-automated process for the production of BIM models in IFC format from 3D point clouds that have been acquired of the building or infrastructure using terrestrial laser scanning. Actually, the input data could be 3D point clouds from other sources, but this is what we have focused on. This is also because this is common practice at the moment to acquire, or common state-of-the-art practice to acquire the state of a building. What are the key functionalities of our tool? I guess the key functionalities are the automated detection and modeling of the following components: walls, slabs, and openings inside the building and on the boundary of the building. And then also we have functionalities for the automated detection and modeling of some MEP components. More specifically, looking at air conditioning units, vents in the ceilings, sockets and switches, and some radiators. All this is a little bit illustrated in the images below, where on the left-hand side, underneath the text, you have the point cloud, and on the right of it, you have the BIM model extracted for that particular building. It's actually a multi-story building, but we only show one floor here. And you can see the IFC model exported, shown both in Solibri on the right-hand side and inside Revit on the left-hand side. I will get back to Revit in a second. On the right of the text, there's another set of pictures that show essentially the process we use to extract, detect MEP components in the individual scans acquired during the scanning process, and how we then add them to the IFC model at the bottom here. On top of this, we also have a manual editor that enables us to add non-visual information. For example, the material layers of walls and slabs, but also properties of, for example, MEP components, or some properties of the openings, for example, the type of windows, double glaze, single glaze, etc. And finally, the editor enables us to select the spaces that we actually automatically generate from also in the process above, but group them in zones. And this is important for doing energy analysis, understanding, allocating energy sources to where it is consumed. So for example, creating zones like where is there an apartment? So all the rooms that make up an apartment. Okay, next slide, please. So what have been the lessons learned? We have applied this to actually a couple of different pilot sites. Very quickly, what we realized is that point cloud quality is very important, and we've been surprised with some of the point clouds we have received. Some of them is not the fault of the surveyor at all. It's actually the fact that in the context of renovation, very often apartments are inhabited. And so there is a lot of occlusions inside the different rooms. And it's very important for the automated process to work effectively that occlusions be reduced as much as possible. So there's a bit of a planning and understanding of the process by the surveyor, so that they ensure that, for example, enough data is acquired of a wall that may be mostly covered by a wardrobe, for example. So if there is a little part of it that is visible, then they should ensure it's scanned. We've gathered all these guidelines into a free guide, a paper that we published called Laser Scanning for BIM. You can find that online. Now, beyond this, we know some of the good performance of the solution. We believe that an automated or semi-automated scan to BIM process like the one we propose can save up to 40% in the scan to BIM process. So current practices would be to bring the point cloud in Revit and manually model from Revit. Or actually, I say Revit, could be ArchiCAD and other equivalent tools. But we think semi-automated process like this can save up to 40% of that time. So really worth considering. But certainly there are improvements that we would like to see, and the end users highlighted this to us, especially when we report the BIM model based on the point cloud. They would like to have some level of confidence that what has been modeled is correct, and naturally they will go and check. But it would be good if the algorithm also gave some level of confidence, and I think we can do better. At the moment, on the top right figure here, you can see a colored point cloud that shows the distance of the points to the element that has been modeled from them. And it gives us some good confidence that the walls have been modeled correctly, and actually also the slab and ceilings. You can't see on this one, but it works well. But the person would want to check. There's a lot of red here, but that's because these are elements that are not modeled, like wardrobes, for example, or beds or stuff like that. Now, another big thing that came out is that we output our model in IFC format. It works very well. It can be then edited in some tools like ArchiCAD, or actually it works well through our pipeline that you will be presented this morning, but it cannot be edited in Revit. And we know Revit is widely used in industry, and that remains a challenge, but it's not an issue from us per se. It's a more an industry-wide maybe complaint and also a challenge to be addressed. And that's it. Thank you very much.
If you can move to the next slide, please.
Yep.
Now, this is the second tool involved in this process and in this stage. This is the ARIPFA tool, which is responsible for presenting in augmented reality the BIM model of the building on top of the actual building to be renovated in situ. And its scope is to complement the scan to BIM capabilities presented by Fred in order to add component information and MEP models directly within the building from the surveyor. So the key functionalities of this tool is to accept the BIM model in IFC format as exported either by scan to BIM or from Revit or from somewhere else. And then the user to wear the augmented reality glasses and walk inside the building and use the tool to semi-automatically detect building components. For example, as you can see here on the right-hand side, we were able to detect an air conditioning cassette unit, and then to annotate the building components where some information may be missing. For example, characteristics like dimensions, layers and materials and thermal properties. And for MEP components, some of the characteristics based on the type of component. Along with that, the user has the capability through this tool to report issues, for example, structural damage or some elements that haven't been installed correctly, or things to be done in future tasks regarding the renovation. And finally, one of the capabilities of this tool is to enrich the model by registering unrecognized and unregistering building components within the space. So after the detection of these, the user can update the model on our building information management platform. And we will show later on how this can be done in the demonstration in the video. Going to the next slide. Some of the lessons learned through the validation activities that were performed in the pilot site. So for the accurate registration of the BIM model in the actual... I'm sorry, Maria, you're muted. Can you mute, please? Thank you. So for the accurate registration of the building on site, so you can see the BIM model correctly following the actual building. The 3D model of the building should be split into floors and then use a registration image target per floor to have a better registration. Since the application is running in a small device with CPU and RAM restrictions, the IFC editing functionality is challenging, so we cannot really visualize directly the changes happening when the user changes, for example, the thickness of a wall or the dimensions of a wall. So this is something to be done on a later stage. Entering text is a generic restriction of all augmented reality applications. So since you are tapping into the air, it's very tedious for large text editing, so descriptions of components and activities, etc. So the user movement speed affects the object detection functionality. So the users need to be instructed to move slowly when they are trying to detect components. And from the user side, we have some of the lessons learned, like that there is a need to have a good internet connection when you need to update the models, because since the BIM model is a bit large, you need to send and receive files of a large size. Users in different locales need to accurately place themselves within the building so that the registration happens correctly, because when you are at the boundaries of a model, this may affect the registration. Good illumination is required both for the detection of elements and for the registration. What we have gathered from our evaluation from actual users is that they appreciate the dictation capability instead of having to type things on augmented reality keyboard. So voice commands are very much useful. Things are, according to this, go to the typing of sensitive information, for example, passwords. So since the user cannot really use an actual keyboard, it's very important for them to be able to check what they are writing, even if it is a password. And for this, it is a good thing to have caching of the user's password in the application. And finally, this is a specific thing for the HoloLens device, to have a complete termination of the application. Since if it is staying in the background, it drains the battery even if you're not working on the application. These are some of the lessons learned, and we will show the functionality in the video. Thank you.
Thank you very much, Thanos. We move to the next tool, which is the BIM management platform developed by UCL.
Yes. Hi, Ari.
Diego, the floor is yours.
Yes, thank you. So the BIM management platform developed by UCL is a cloud-based integrated data management solution, and is responsible for storing, versioning, enriching, updating, checking BIM models that are conforming the IFC standard. The key functionalities of this tool is that, as I said before, it uses OpenBIM standards, and it works with the IFC4 version specification of from BuildingSmart. And this tool contains components in two different categories. We have first components related for data quality checking, and here we provide two tools. We have the geometric error detection tool that is responsible to provide visual reports to the designer in order to see if we have incorrect placement of spaces or not well-defined spaces, and because the spaces are required for the correct generation of the energy model. And also we have another tool that it works with the MVD rules, and is responsible to check the incoming files from the ARIPFA, from the previous tool, in order to ensure that all the properties that are required, such as thermal properties, MEP components properties, are complete, are in place, included in the model, in order to be able to generate later from other tools the energy model of the specific building. In case the digital twin, the BIM management platform provides also the enrichment in a category that is responsible for model enrichments. And here we have the CBP algorithm that is responsible to enrich the model with a second level space boundary topology that is required for the creation of energy model. And we use this functionality only in because, as we said before, the file is produced from scan to BIM, but the BIM management platform works also with files that are exported directly from Revit, Autodesk Revit, and ArchiCAD. And of course, the user has all the information in the viewer, so she can see all the missing properties and then to go back to the previous tool in order to update the model and at the end to have an error-free model. Next slide, please. Yes. So yes, we have a lesson learned during the validation of this tool. As I said before, the digital twin platform provides OPJ files for the error part, for the reporting the errors. So this is very useful for other tools that works in Unity or other platforms like Aripfa, in order to send these files and visualize in low level all these errors in order to notify the users. Of course, the digital twin platform, the BIM management platform, sorry, provides also other formats for error reporting, such as HTML, JSON, and BCF. We are using also the building collaborator format, BCF, from Building Smart. As I said before, we use this iterative process, so the designer uploads the file to the BIM management platform. And if the file has errors, we give the possibility, the functionality to have different revisions of the same BIM model, and using this approach, we can track all the changes and all the improvements of the model until we have at the end an error-free model. And in order to help this file exchange with users and other BIM software component, BIM authoring tools, we are using the ISO 19650 in order to have a correct naming convention for the names of the files. Now, the lesson learned from the users, as I said, the BIM management platform receives as an input the scan to BIM file, but also files generated directly from the BIM authoring tools. So we have tested all these functionalities, and we have create guidelines for exporting correctly IFC files from Autodesk Revit and ArchiCAD. And as I said before, we are using the building collaborator format in order to notify other BIM tools for the issues that are existing in the model. Thank you very much.
Thank you, Kyriakos. Now, just to sum up, so far we have presented the three first tools of BIMERR used for the as-is building information extraction. That is Scan to BIM, Aripfa, and BIM management platform. A video has been prepared with a demo usage of these tools. So thank you, Thanos, for in advance, and I'll start the video right now.
So as we have said, the process here starts with the Scan to BIM tool, where the user starts by selecting the project that they will work on, and they select the point cloud files that they have captured from the surveyor from the building. They define some parameters for this point cloud, for example, the voxel size and the cloud resolution and the openings voxel size. And then they run the process so that the scan to BIM algorithms generate some information regarding that point cloud. So basically, first the floors are detected and they are separated into different elements. And then structural components are automatically detected in the point cloud and model. For example, the walls here, as you can see, are overlaid on top of the point cloud. Here you can see slabs as they were extracted from the point cloud. And then you can see here in BIM model viewer how they are separated as openings, as doors, walls, and windows. And finally, the slab will show clear. Now, you can see here within the viewer that the user can check everything that has been done correctly. And afterwards, the system is used to separate the different spaces. And we will see later on how these spaces can be combined in order to create second level space boundaries. These are automatically calculated. So basically, what adjacent spaces are combined based on their distances, and they are generating space boundaries, second level space boundaries that correspond, for example, to different zones, and they can be combined into zones, for example, in order to define apartments and other areas in order to be used in calculations, for example, for energy efficiency at an apartment or a common area level. See here you can see the different second level space boundaries for the first floor and the second floor in Solibri. As you can see, the results of our scan-to-BIM solution is opening different existing applications. So another capability of the scan-to-BIM is to edit some of the parameters in these components. So if you load the IFC generated by scan-to-BIM, here you can see the components as they are generated with the walls and slab information. The type of IFC element you can see here on the third column, the name assigned and the IDs, and the thickness on the last column. So for any of this type of components, you can select the category. And for example, here you can change the materials. And you can select, for example, the general category of material, concrete, subcategory, and the exact material used. And finally, define the thickness of this element.
Just to add that these elements, they come from a database that will be presented later from another partner. So they are a web, it's a web server that contains materials that are used, that are commonly available and used.
Yes, correct. This material database is loaded within this application, and it is also used in other applications as well, as we will say in the next stage of the project. Now, after that, we have the profiling, residence, and usage system. So in this, you stopped? Paris? No, you went back. Okay.
I'm sorry. Can you? Is it? Yeah.
Okay. Sure. Continue with the video.
I apologize for that. Yeah.
Okay. So after the parameters have been added, the final IFC model is updated with these parameters. And then this can be uploaded, this can be defined also in Windows and MEP components detected through the scan-to-BIM. You can see here an example of different IFC windows. So multiple selection and assignment of materials can be done in one go. So you don't have to individually select each component. So for multiple windows, you can select the same pane material. The end result you can see here in Solibri, where when you select, for example, a slab, you can see the thickness added in the previous step in the editor and the material used, concrete. Finally, then these spaces are merged, as I said, into zones, defining different apartments in different areas in the building. Here you can see the creation of a new zone. And this is how it appears in a visualization tool like Solibri. So finally, these are uploaded into the interoperability framework of BIMERR as an IFC file and assigned to a specific project. And with project here, we mean the specific building the renovation is going to be performed on. This is information that we extract from the interoperability framework, the IDs of each project and the URLs to be used. And this will be explained later on into that particular tool of BIMERR. Now, once the model is uploaded, we will go on to the next stage where it is processed by the BIM management platform, which is, BIM management platform, which is used in order to perform, as Kyriakos said, some checks on the building, for example, for geometry and completeness of information for its component. So this is the model that we have uploaded from Scan to BIM. We can check with the integrated 3D model viewer. And then we can run a geometry checker in order to detect any problems within the geometry itself, for example, overlapping elements and things like that. After the check has been performed, there is a report that says some errors with, for example, detected, and we can see here how we can separate different elements of the building by story. And see, you can see here class error. For example, you have a wall overlapping with another wall, and they are indicated by colors. And here's the report as it comes out. And after the geometry check, the check model can be uploaded back into BIF with the changes with the report attached in the MDT file. And here we can see the same process as we can perform it into an externally generated model, for example, from a Revit file. This is the model as it appears after it's been imported from the Revit exportation into IFC format. And we can do the same kind of check that we presented earlier into this model again. And here is the final result and the report. This one was error-free with regards to geometry. The second functionality for checking is completeness of information regarding the components. So what information is missing from different elements that needs to be there in order for the model to be considered complete. We will see here the report that is generated for this particular model. Here you can see for the thermal properties of some of the elements, we had 99 valid instances and 1 invalid. So if we go back to the 3D model viewer, we can check where that error appears. So it is based on a slab of the building. And the missing element information is the roughness, the conductivity, the density, and some other parameters. So we can go back and modify these parameters and add this, for example, in Aripa, the tool I showed earlier in augmented reality, or in Revit, or in any other tool. And then we re-upload, and the completeness checker will provide zero error. Now, the CBIP tool is used in order to extend and enrich the file with this information. And the final model extracted from this operation is the enhanced IFC file that can then be considered as the final version of the model. with all geometry and completeness errors correct.
May I add something to?
Yeah, Kyriakos, please add
Or
whatever you want.
I'm Yorgos. Anyway,
Yes.
so CBIP enriches the model with the second level space boundaries that you see in this video. The second level space boundaries essentially are surfaces for thermal flow exchange among building spaces and the environment. So it's important this information to be inside IFC to have a complete and correct energy model in order to perform energy simulations. So CBIP does that. Thanks.
Thanks, Yorgo. And this is the result after the generation of the second level space boundaries. And as you can see, we can separate different elements and visualize just the ones that we need.
Yes, also the surfaces that you see are have different characteristics with different colors. So, and also I would like to add also that the MVD checker also performs checks for the topology of the second level space boundaries to ensure that is correct.
Now, at the end, we generate, except from the IFC file, also some different models. So inside the BIMERR, we use a building data model definition. And we also see here the MVD files and also the CBIP generated enhanced IFC file. And we can synchronize all these files with the building interoperability framework. So the latest version of everything is uploaded. Now, part of this is the generation of the OBJ files, the mesh, let's say, 3D models that are used for visualization in other tools like Aripa. And as I said earlier, the MVD file as well that was generated through this process can be uploaded and used from other tools from BIMERR and outside BIMERR. Now, after that, we can see how Aripa takes this IFC, the enhanced IFCs was generated. We can go and log into the interoperability framework and select first the project that we'll be working on. As you saw here, this is how you enter text. And you can understand that in augmented reality, it is a bit of a hassle. First of all, we will try here to see if there are any missing components, NEV components in the building. So we have an external tool running in a server that performs this detection. So the user can log in into that server and then go around the building. First of all, select that this is the creepies, for example, building that we are working on, or one of the pilots that we had in the project. And then load the model of the building, either a section of it by floor or the entire model. And where to download from, we may have already a version stored in the device or download from the interoperability framework. And now, first of all, in order to be able to provide an augmented reality visualization, we perform a registration, which is scanning for an image target. You can see an image here posted into one of the walls, and that corresponds to a specific location in the BIM model. And then you can see here overlaid on the actual building, the BIM model of the building as generated in the previous step. Now, if we anchor the 3D BIM model, it's going to stay there and we don't have to re-register again. Now, the user can have some speech commands, as I said earlier. For example, show location can tell the user what IFC space they are currently in. So you can see here, we are in kitchen number whatever. So the user knows exactly what space they can modify. They have to modify the parameters for. The IFC properties of each element are demonstrated by clicking directly on the element as they see. And some parameters can be directly modified, for example, dimensions and thickness. And here we can see the capability to add annotations to different elements. that can be used later on by other users. So this can be sent, for example, to the construction company to indicate some remedial work that needs to be performed, or the status of the work that has been done, the type of annotation, if it is regarding the architecture or the stages of construction, and what priority to be given to this annotation, some description of the annotation, and also you can see in the future to provide some media attached to that annotation. For example, capturing an image, photograph coming from the camera of the AR headset. And the user can also capture a video, which can be used in order to further indicate what needs to be done in this particular case. Now, this annotation will stay in place even if the user logs out, and then they can reload that annotation and see what has been done. The capability to add missing element parameters is done by clicking, as I said, on the component. And you can see here that it's missing some properties, for example, a name, heating point, and a cooling point for this thermostat. This was indicated with a red color. So for any element in the building that we have missing parameters, we indicate it with red. The user can also use as part of the HoloLens capabilities voice to text. So these numbers can be added by just saying 28 or 18 in this case. And also one of the capabilities is to see the tasks that have been generated in the PWMA toolset. And here you can see for this particular IFC space, this is the list of tasks relative to it. Finally, the capability to add MEP component to an IFC model is demonstrated here. So we are using the server, as I said earlier, that detects this cassette, for example, this air conditioning cassette. And once it is detected, the user can add a placeholder tube in the place of the element. Unfortunately, we don't have the capability to add, a detailed model that matches an air conditioner, for example. We just add a placeholder element, and we can add the parameters of this component directly into this model. So if we enter that, we can add the relevant parameters. Since this is detected as a unitary equipment, for example, an electrical equipment, we can add heating points, cooling points, capacities, specific type of handler, etc., air conditioning unit, split system, etc., based on the detected type of element. Now, once this is done and all the elements have been detected and all the parameters have been added, the user can upload the edited model directly into the interoperability framework, and this can further be propagated into the BIM management platform, again, to be checked for geometry and completeness errors. This is the part where we are exporting this into IFC. And finally, the user can quit the application at the end here. When they quit, you can upload this, the changes they made, and create a new version. And based on the version number here, you can see in the BIM management platform that we have a new version if we synchronize. That this is a completeness checked model, and this is the final model with the changes we performed. And you will see here that if we go inside the space we were earlier, a new here is missing the element that we detected earlier. But if we perform a synchronization and download the latest version of the model, Now we have a new MVD report, and we have a new HVAC added.
Something to add here, that here we see that we have 13 valid instances, and now we are going to proceed with synchronization. Yes.
Okay.
So now we will see one more instance, that is what ARIF application has added before.
Yeah. See, here there's a model uploaded by ARIPA. It is pending checking. And finally, the model has been generated. And going back into the living room where earlier, you will see the cube we added that has been on the ceiling there. And if we run a completeness checker, we can see here that the new parameters have been added for this element. And we have 14 instead of 13 that we had earlier. Here is the report. And then you can see here at the end, a detected model. And it is a valid model. And this is then uploaded into brief, and we will go in the next section, and somebody will explain this better than me. Thank you very much. Aris?
Yeah, I'm sorry, I was muted. So with this, we conclude with the first phase of the BIMERR tools, the tools that are used to collect the as-is building static data. In that case, we have reached the first milestone, and we proceed to the second phase of the as-is building dynamic data collection. In this section, as Ottilia mentioned, PRABs and BICA are being used. So we shall proceed with these tools in this section.
Anis, we would have now a couple of 2 minutes or 3 minutes for questions, right?
If I'm correct, yeah, you're right, Attila. We have some time. So if there are some questions so far from what has been presented, we're of course open for questions. Just one more thing for people who joined a bit later. In the beginning, we kindly asked external participants to kindly please mention in the chat their role and possibly, if they wish, the organization for which they work for, so we can have an image of the audience that was here today. So thank you in advance for that.
Then again, any questions or comments? Right, that seems to be the case.
We can then proceed, I suppose. So, Yorgo, the floor is yours.
Hi, Aris. Hi, everybody. Can you hear me?
Yes.
Okay, great. So now we're moving to phase 2, where we actually go beyond BIM, and more precisely, we collect first dynamic data required as input for more accurate prediction the as-is building performance and for the impact assessment of potential renovation measures before being applied in reality. And the second, residents' feedback concerning the current status of the building, indicating its weak points and occupant comfort zones. And to meet these requirements within BIMERR, the profiling of residents' usage building systems service, PRABS, and the building information collection mobile application have been developed and delivered. And I'll start with PRABS. Aris, next slide, please. Starting with its scope, actually, PRABS scope is to train occupant behavior models, which are actually formulas that given specific inputs, they can predict, simulate, or forecast the occupant comfort bounds, presence, and residence control actions upon energy systems. Actually, the trained models are mainly used as input to building energy performance simulations performed by another BIMERR tool that we will present later on. And main scope is to improve the accuracy of the BIMERR simulation engine results. Key functionalities of PRABS include, among others, the occupant behavior modeling part, where actually we are applying different machine learning algorithms on IoT data acquired by various sensorial metering and monitoring devices installed on the building, like the ones depicted on the right of the slide, and capturing the trained models in OB XML format, where actually OB XML is a standard data model that was developed in the context of the EA Annex 66 project that has been slightly extended to meet the requirements of BIMERR. Next slide, please. Actually, PRABS does not provide the user interface, but it is a backend service that feeds other tools of BIMERR, and mainly the big application that we will see after this slide, and the renovation decision support system. So end users have not been involved explicitly in the demonstration validation activities, but implicitly through the evaluation of the resulted energy performance KPIs for each site. From the developer's perspective, though, we learned that through the validation of demonstration activities, we learned that the commissioning and health monitoring of the IoT equipment is a challenging task and requires significant effort. While frequent maintenance and continuous remote health monitoring of the IoT equipment leads to IoT data of high quality and granularity, and consequently to more accurate dynamic data, which means that with more accurate dynamic data, we can somehow reduce the gap that occurs between measured and simulated performance, energy performance of the building. In this slide, you see some images from IoT equipment that has been installed in our pre-validation and validation sites. And that's it from my side.
Thank you very much, Yoro. With this,
yes, we can continue with the presentation of BICA. And if I'm not mistaken, Nefeli will present.
No, I will be presenting. Carlos, hi everyone. Yes, so BICA, in short, meaning Building Information Collection Application, is a smartphone application that enables the collection of building-related data from the building occupants in order to provide and improve the renovation design and planning before the actual renovation work starts. The key functionalities that are offered by the smartphone application from BICA is that building residents can explore their apartment BIM model, meaning that they can see the rooms that are listed in their apartment, ambient conditions such as temperature, luminance, and humidity, as well as the equipment that is registered in their apartment. Another functionality is that building occupants can highlight various weaknesses or issues or even faults that is happening with some of their equipment, exactly radiators. As Giorgos Giannakis said, through the BICA, the building occupants can report their actual comfort status against the current ambient conditions in their rooms and in their apartment, which can be used later on for their comfort profiling. And our last functionalities is that the users can actually declare their preferred room usage, which can be used for optimizing the renovations work scheduling. If we move to the next slide, Aris. Now, in terms of lesson learned, as far as the developers are concerned, we identify that early availability and correctness of the respective building data model and its formations, such as the building, the zones of the building, the spaces, and the elements contained is prerequisite, along with the early and continuous validation that the relevant fields, such as the space ID, the rooms, let's say, are included in the apartment sensor data, so that the user can see the correct installation room of the devices. And also that we need to have users related to specific apartments, so that they can see the information of their own apartment. Now, in terms of lesson learned for the users, we got some feedback, valuable feedback, saying that the BICA app is a helpful one for the building managers, as well it's non-intrusive for the residents, as we do. Normally, you have to bother them to ask their opinion, to ask for any issues they can report. Users recommended to have a detailed instruction manual, which will help them to install the app, as well as having a multi-language interface will attract more users which may not have English knowledge. You can see some screenshots of the application on the right-hand side, but we will go in detail and show more in the demo. That's all for BICA.
Thank you, Spiros. Yes, in the next slide, we have incorporated the demo video. So,
Okay,
is it
you can start.
you or Nefeli? Okay.
I'm going to be presenting. So as you can see here, when the user first opens the application, he has to provide us in any application his credentials, username and password. And this will direct them upon pressing the login button straight to the home page, where they will be able, as you can see now, see the outdoor conditions where their apartment is, some indoor values about the rooms. From these buttons here, they can also go to the other features of the BICA, and at the bottom, they can scroll and go into the different rooms and see the devices listed in each room. Using the hamburger icon and through the main menu of BICA, users can see the rest of the features and the functionalities. So by pressing on rooms, they can see all the listed rooms in their apartment. And by pressing on any of those rooms, let's say living room, they can see further details, such as the indoor conditions and the devices listed in their apartment. They can, as we said, provide a comfort status against the current ambient conditions. For example, here you can see for actual humidity 42, they can use this 5-scale emoji and say, for example, that they feel comfortable or uncomfortable, and save this information. This information is used later on for the comfort profiling. Now, they can also, as we said, declare the preferred room usage. So as you can see, they can say, even if it says living room, they can say that this is actually a bedroom. So this can be taken into consideration for the actual planning of the renovation works. And so also by clicking on any of the devices, they can see information such as the type, the model, and the manufacturer of each device. Now, another functionality that we can see is the components, where they can actually see all the components listed per categories, all the components in their apartment. They can also, as we said, report an issue. So they can select a specific room where the issue stays present. So let's say the living room, they can say they have select the space heater, and select the category. If it's going to be health and safety, it's going to be a maintenance problem, which is the case here, and provide additional information which can be used by the renovation contractor. Let's say the heater needs maintenance or provides further information. The user can also, you can see, attach a photo, an image showing where this equipment is, or go into further details, take closer photos of the equipment itself. They can, by pressing the send report, now this report is sent to the renovation contractor to be managed. Lastly, they can, through the report log, they can see the actual report they created and all the detail and review it at any time. And finally, as a side functionality, through the main menu again, through the settings menu, the user can edit the personal profile, so change the gender, the age group, and the number of occupants. As well as at the bottom, they can change the password without needing to log out from the application. Thank you. I don't know if you have any questions.
Alice, if you are speaking, you're muted.
It seems that there are no questions, so we can move to the next phase. And I will pass the floor to Stefan.
Hello, everybody.
Yes,
Stefan. I'm Stefan from Xylem. We will now present Reno DSS in a third phase. So if you go to the next slide, please. What we are doing now is we take the IFC, which was generated from scan to BIM, going through BIMMP and ARIPFA, as an input for Reno DSS, which is about finding and selecting optimal renovation scenarios. So what we are trying to do is we are taking the IFC file as an input, ask the user regarding his preferences in the renovation project. So if he wants to do the floors, walls, thermal insulation, window exchange, and then use this data to generate renovation scenarios. For each renovation scenario, we calculate the KPIs. So we have energy KPIs, which like heating demand. We have sustainability KPIs, which is about like the global warming potential. And we have financial KPIs, which is, for example, the costs of heating or cooling of the building and also the operation of the building. So we calculate these KPIs once for the baseline building, so as it is, and then we calculate the KPIs for each renovation scenario. So one renovation scenario is, for example, a building with 30 centimeters EPS insulation on the outside. We calculate how much this is in terms of construction, and we calculate how much energy savings this will have in the following years. So everything is web-based. So the entire software, Reno DSS, you can access it over the web browser and configure your renovation scenarios. And for each of these renovation scenarios, we will output a PDF report, which has all the details lined up of the renovation scenario, and also an IFC file. This enables you to take the IFC file, which is an output of Reno DSS, to use it within your favorite BIM editor afterwards. You can see the PDF report here on the middle picture, and on the right-hand side, you can see, for example, Kripis, which is a pre-validation site, including all the KPIs, which we had calculated, and you have sliders, and you can like restrict the KPIs in each category to see what's left, but we can show this in detail in the demo. Next slide, please.
Miriam, can you hurry?
Sorry, next slide, please. Aris?
But this, yeah, I'm sorry.
Can you not go see to the next slide? Now I'm at the video. Is there one slide back? Yes, exactly. And the lessons learned. So we have run Reno DSS together with the BEP module. The BEP module is developed by Hypertech and responsible for energy KPI calculation. So it's based on Energy Plus. We have run both BIMERR outputs in the pre-validation sites, in 2 pre-validation sites and 2 validation sites in Spain and Poland. What we have learned there is that the BIMERR material and component database, Fred mentioned before, is key for gathering all the required data for the materials you would like to use in your renovation scenarios, but also for the materials in the baseline. So there's things like conductivity, solar reflectance, costs of the materials, and so on and so forth. So we have seen in the validation activity this takes some time for the renovation designer to input this data. But in the end, the automation aspect of Reno DSS makes the time worth. So you can output, I don't know, 70 renovation scenarios quite quickly and without manual effort. So it's quite scalable. But this initial phase has to be done with filling out the data in order to give the tool the necessary input information. The P-set definitions were quite important. So we defined P-sets for like windows and so on, so that we know have a common standard of how are the attributes of a window, for example, called. And this was crucial to the BIM to BEP process transformation, where we are actually transforming the IFC model to a model which can be processed by BEP for the energy KPI calculation. From the feedback we got from the users was that it has a great potential for commercialization. We also studied how much time can be saved by this kind of tool. As I mentioned, giving the input data takes time, but this would be also the same time in a manual process. But where Reno DSS really stands out is that it's quickly combining all different like combinations of renovation options you have defined before, and generating for you the scenarios, including KPIs for comparing the scenarios, plus the IFC file for refining the renovation scenario afterwards. So next slide, please. I guess we are then at the demo. Yes, now you can see here the input of the login window of Reno DSS. So we integrated with the BIMERR identity provider. So this is also one aspect of the interconnected BIMERR tools in this project. You select a project, and what it does, it loads the IFC file of this project I mentioned before. It gives you baseline data right on the right-hand side, so like how many square meters, what construction year. It shows you the location on the left-hand side. And then on the bottom, you see the materials I mentioned before. So you have then different materials from the baseline, like concrete, insulation material, and so on. And if you click on the green button, you get this material properties window, where you can fill out missing properties. For example, if you get an IFC file, you might have the thickness of the material, of the layer in the IFC file, but you might not have the correct conductivity value or global warming potential of this material. So it would be a lot of work to research this on the web. Therefore, the BIMERR material and component database is there, where we have a lot of building products and components inside. So you can simply look for a similar material here and map it to your component. This speeds up the data input effort significantly, as you can imagine. And the same we have for like building materials, but also for windows and so on and so forth. And the rest is coming like, we take everything which we can get from the IFC file, and what's missing has to be completed in this exact phase you're looking here right now. Apart from that, you can configure other stuff like analysis periods. You can configure the sustainability parameters or the cost of electricity and escalation rates and so on and so forth. So you can, for the LCA calculation, you can fine tune here a lot of parameters. This is what you see is the urban planning module. So we are not only considering the building for itself, but also in relation to its neighborhood. You see here the network grid in the surrounding area. So this, in this case, electricity lines, which are in the streets. This is demo content. And you also see how the energy flows in this neighborhood are. So basically, we have an input for each building, how much power is when produced and consumed. The same for our building, for our renovation project. And then we can see how much power is flowing in and out from the buildings. Because if you are taking a bigger perspective, you can also say that it might make sense to install, for example, PV on the neighboring building if this provides the necessary roof space for it. Here you can see the KPI view. The KPIs I mentioned before are listed here for the baseline. So you have the sustainability, energy, and economic KPIs. The energy KPIs are coming from the BEP module from Hypertech. We also have time series data. So not only static data, but time series data as well. The economic ones are coming from the LCA and the sustainability from the LCC module as well. Here you can define the measures. So if you have the baseline building, you can define here what is reasonable in this building. For example, insulating the walls, insulating the roof, changing windows, and so on and so forth. So on the right-hand side, we have here constructions, default constructions you can choose. You simply select the building element, in this case, the outer walls. You define the conditioned side of this wall, and then you select one renovation construction, which is, for example, take off the existing insulation and put in new insulation. You can see on below the materials we use. You can also like say, I want to try 10 centimeters insulation. I want to try 12 centimeters insulation. Let's see what performs better. So you can also like duplicate the layers here and say, I would like to have alternatives here. The same goes for roof. It's the same. So you have a roof is shown here, and you might insulate this roof or do other stuff with it. Also for the roof and the floor constructions, we have default constructions from our library, and you can also tell what kind of layers are coming out of this construction if you put the new one on, so that you can say, for example, I would like to remove the old insulation and put a new one. And for windows, it's a little bit easier, I would say. So we have the windows. You can select also a group of windows, and then you can like select a new one, and this would be applied on this window group afterwards. For all the renovation materials, you can change the parameters you're seeing down here. So like the installation costs, construction costs, and maintenance costs, disposal costs. This affects then, of course, the LCC KPIs. Here we are the last screen of RenoTSS, which are the scenarios. So once we know what kind of measures are okay for you, RenoTSS automatically generates different permutations of these measures, and this will form the scenarios. So one scenario might be 12 centimeters EPS with windows exchange. Another one would be 20 centimeters exchange, but with rooftop insulation. So you can imagine that there are quite a few combinations. And these combinations are then listed here. So you can click in each scenario and see what's inside, so what kind of measures are there, how much is it in terms of euros, construction costs, what are the savings, the yearly savings of this, what's the payback period of this scenario, and then you can easily, and also other KPIs like this, the global warming potential of the scenario. So if you want to go for a green alternative, you can do this as well. And you can then sort this or filter these scenarios. You would like to say, I would only like to have scenarios with at most 600,000 euros and with a very good global warming potential factor. Then you can filter this on the right-hand side. And this user interface is designed to come together like economic buyers, political decision makers, but also technical people to look at the possibilities you have for this building and explore them together. And then like identify one or two scenarios where everybody's fine with, like the economic people are fine, the technical ones are fine. And then you can generate the PDF reports for these kind of buildings to forward them where all the detailed information about the project is listed, so that you can forward them to like the decision makers in the end. What's also important for each scenario, you can download an IFC file, as I mentioned. So you download this IFC file and then you can open it in Revit or Archicad or in other BIM editor to like further modify this renovation project. So RenoTSS reduces your time also for establishing this IFC file for the post-renovation status or for the renovation project itself. This also comes with RenoTSS. And if you click on one scenario, like shown before, you can then see all the measures which are included in the scenario, how much each measure is, how many square meters we are there. This is mainly for checking if the calculation was correct. Yes, that's it from my side, and I'm happy to take your questions. Thank you very much.
Questions or comments? All right then, Alice.
Yes, thank you. Now we can proceed to the last and fourth phase of the renovation using BIMERR tools. This is the renovation planning and actual implementation, the construction. So if I'm correct, Damiano shall be presenting. Good morning, Damiano.
Yes, good morning, everyone.
The floor is yours. Thank you.
Thank you, Aris. So yes, this last phase is about the renovation planning. So we will present a toolkit named PWMA that allows to first design a model, the renovation process, execute it, and also monitor its progress. Next slide, please. So the first part will be about the modeling component, including the simulation toolkit, and this component is responsible for allowing the graphical definition in form of BPMN process of the renovation process, and this definition allows also to simulate in order to optimize and have a decision support system for improving the process in case of unexpected events. The key functionality of this toolkit are mainly the possibility to have a first design thinking workshop in order to define the requirements and the digitization for the renovation site. The possibility, of course, to create this renovation process model in form of a BPMN model and have actually a business process management solution. The possibility to simulate and analyze this renovation process model in order to check first if the model is correct and then evaluate the times and cost of such kind of process, to collaborate on the renovation process definition and also document the process in integrating platform like Microsoft Teams or Atlassian Confluence, and also to define risk and key performance indicator, so KPIs associated to the process. Monitor such kind of KPIs over the process execution, and also define the services and interactions between such kind of services needed at execution time. Next slide, please. So what we learned during the validation is that actually in the modeling phase, we really found helpful the usage of templates, so predefined templates that define for different type of processes. And these templates are used to reduce the modeling time, but also are being seen useful also for the definition of KPIs and for the parameter needed by the simulation. For the user side instead, we have seen that this tool is not seen mainly for the execution level, but mainly for the planning and management of the renovation process, and so extracting the knowledge and also collaborating. And the complexity is let's say adequate for the work that had to be done. This is also in relation with the Gartner that defined this tool as a Customer Choice Award of 2022. And of course, this is after the let's say minimum set of knowledge that the user need to have, like the knowledge of the BPMN process that can be acquired through training, like freely available, for example, from the BUC company or by any other external partner or consultancy company. So also another point was that this toolkit, I mean, not all the renovation process have to be modeled, but the user can focus on the specific part in order to analyze specific problems. And because usually this modeling may take time, especially not the modeling, but especially the simulation, definition of KPIs and monitoring. So maybe the user could like to focus on specific part. And also to use this as a communication and collaboration platform. So having this as a way to share the knowledge about the renovation process that had to be applied. Next slide. That's all actually from my side. We will present later the demo. We will go now on the execution phase. I think Martin will be the next. Thank you.
Thank you, Damiano.
Okay, greetings to everyone. I'm Martin from Logitech. So to summarize, that's the BIMERR for manager. It basically generates a workflow that is then run to track the guide to the workers on the renovation process activities. It then allows the renovation designer or planner to define different workflows for different types of jobs or processes for the design, construction, and delivery of the works. The main functionalities of the BIMERR for managers are the creation of detailed workflows and work orders and assignment to specific providers or workers. And then the workflows or work orders contain the information about all the tasks that need to be done, along with the data of the specific building and its components and other workers, other details, and so on. Next slide, please. Thank you. There are several lessons that we learned during the development and validation phase. So the lessons, according to the developers, are the first point is that the work processes should be more diversified, and we should have the ability to assign multiple work orders. Multiple work providers or workers to specific task, and also multiple locations, because this was directly requested by the stakeholders. The second point is that the states of currently working providers could be visible to the managers in the PWMA for managers for an easier planning and mitigation measures if there's any issue or problem. And third lesson learned, albeit a minor one, is that the process of KPI measurement and calculation could be potentially partially automatized with the PWMA toolkit, but this is a minor suggestion. Regarding the lessons learned from users, the PWMA for managers provides an effective and seamless experience for managers, which allows them to efficiently manage work, data, and persons of interest. Okay, next slide, please. Thank you. The second application directly from Novitec is the PWMA for workers, or how is it called, the application for on-site renovation worker support. So the scope of this application is a dedicated application or applications targeted to supporting workers in the renovation site. When we talk about workers, we basically mean the contractors, workers, and their foremen, and then also building residents, although this is more relevant to the PWMA for residents that you will see in a moment. The key functionalities of the application is that the worker can see the assigned work orders, their descriptions, available tasks and their descriptions, and also state of the work and each of the tasks. They can then ask for remote assistance while sharing their camera feed, capturing and sending the pictures, videos, and audio files, and also the documents during the work order execution. And then their work is automatically reported and logged as specific results and values. So the values gathered during the work are then summarized and visible to the managers. Right, please. Thank you. Then we the lessons learned, the main lesson learned for the developer side is that the workers' application and notification system are sufficient for the working field, provided that the users are introduced to them and taught to work routines within them. Because the main issue that we encountered while testing the PWMA for workers is that the notification system that we created can be a little bit cumbersome to use if the user is not accustomed to using it. Okay.
Thank you, Martin. Moving on to the last application of the PWMA toolkit. Thano, floor is yours. Thank you.
Now, the last tool revolves around the residents of the building and how they can be notified on tasks happening during the renovation. So this is the scope of this application, which is called PWMA for residents. It is to support the communication between the residents and the construction team, the building manager. So basically, from this tool, which is an application for mobile devices, the residents can get information on when its task is going to happen, what it involves, and what are the health and safety ramifications of its task. For example, if one task has noise or dust or any other adverse effects. And basically, the user can also provide feedback to the construction team regarding issues they may encounter, along with media they can attach to this health and safety issue reporting, photographs and audio recordings or even video. This is the scope of the application, and these are some of the lessons learned that we gathered. So basically, this is not the one from us, I think. I don't know if this is the correct lessons learned. Give me 1 second. Yeah, I have the presentation in front of me, the correct one. So basically, for the developers, we have some feedback regarding the uploading of multiple attachments per issue. So this was a request that was made. So the interoperability framework was modified accordingly in order to address that. From the user side, there was a reporting issue regarding the size of data uploaded. So basically, the user should refrain from capturing, for example, video in 4K resolution, which is not really necessary, and basically to ensure that they have small videos. So in order not to load the system too much by uploading very large files. Basically, another thing that we noticed is that in order for a new issue report from the users, from the residents, it's best to contain all the necessary information, not just the text description, but audio, images, and video if available, in order for the managers to better monitor what is the issue and accordingly provide remedial work. And finally, that any uploaded media should be descriptive and targeted to related issues, for example, focusing on the specific area where there may be an issue, not the general video of the user. And that's it from the lessons learned regarding the PWM for residents. Thank you.
Thank you, Thano. So moving on to the demo video of the tools previously presented. So
sorry, we have one question in the chat. So I suppose it's about the PWMA. Muslim.
I think this goes to Martin.
So the question is, yeah, okay. Thank you, Martin.
Task planning, yes.
Okay, so if I understood correctly, the question, so basically during the planning phase, we decide all the tasks that need to be logged into the system and provided as a guide to the workers, and these tasks are then made into the process model, which is then distributed into the PWMA toolkit, and the managers are then able to create the so-called work orders from this process model, and these work orders are then assigned to specific workers. So I don't know if this answers your question. Okay. Thanks.
Thank you. So I think we can start with the video. So the first part about the PWMA component is the modeling part. So in this entry page, we have a modeling entry, and this modeling environment is based on the BOC product components and allow is to model and is a full business process management solution. We can see in currently the list of available models divided by templates, instances, and workflows. So we have a set of templates that define all this process, the type of generic process for, in this case, the facade renovation inside of the wall. Sorry, I don't see the video. Maybe I have a connection problem. Okay, yes. Then we instantiate, basically, we use the template to create the effective instance for our specific case. So in such a case, the process is more linear and we avoid decisions. We made pre-made decisions. And then we refine this, this instantiated process in the effective workflow that will be executed. So adding, for example, service activity that are automated, or improving the description of the manual activities. Like in this case, we see that, for example, we added some automatic activity at the beginning made by the IT system in order to notify the user about the starting of the activity with some parameter needed by the services. This model are then used, exported, we'll see later in the execution environment. In parallel, we can create the KPIs. So with KPIs, we can describe not only the KPIs, but also the metrics and the data used to calculate these metrics. So where this KPI value are retrieved. In this case, for example, we have this blue object where we specify the type of services used to retrieve the data. So we have, for example, service ID and the service parameter as input. This is, we will see later, actually all the services are created. And the green one instead are the metrics. So that define actually the formula that combine this data from the different services in order to then return the value of the KPI. In this case, the function is just a subtraction. And we define different type of KPIs. Sorry. Like in this case, we can see one metric for each task of the process, like the install of the waste system. And then this with this circle, we have the definition of the KPI with the associated metric and the target definition. So the threshold that this KPI have to achieve in order to be success. The last part of the modeling toolkit is about the service. So in this model, we are able to actually model the behavior of the service. In this case, for example, we have a service used to log into the authentication service using a REST call, or this other service used in the notification system that is an MTP service that send a mail with the configured parameters or pre-filled message to send. And these services are then exported, and the running services are automatically generated and used by the automatic activity in the process, in the workflow that we previously have seen. So this configuration are actually taken as input and used in this model, in this service. As soon as the model are ready, we can actually show you some features around this model. So if we can see first the available renovation scenario for the different site, like in this case, in the pre-validation site. And in this page, we can perform the different features associated to the model. So in this case, for example, the simulation and the formal verification, and later the execution. So for the simulation, we have a predefined input parameter. We can see that the simulation is did not ask nothing to the user except to be started. So the simulation take as input the model and take as input parameter Excel file and return the result also an Excel file, like in this case, containing the details of the task. In this execution, like for each task, we have the effective execution time with the end time, and also the shows applied. Before actually perform the simulation and during the modeling phase, the modeler can be helped by this formal verification toolkit that allow to check structural property of the model in order to validate the correctness. So in correctness, we means the absence of deadlocks, the absence of live locks, so that the model, as soon as it's executed, will never terminate and will loop continuously, or the reachability of a specific activity, like in this case, the final quality check, that in this case is true. And in case of the availability, we can see why this is reachable, so all the steps that go to this activity. And the also possibility to check the existence of a path between two specific tasks. Of course, we can also combine such kind of verification with negating and specifying if this existence of the path have to exist for every possible path, or at least just one part of the process will reach to this ending activities. As this tool actually is based on a mathematical model, here the result is interpreted and provided as a simple, let's say, text that describe what is actually the property that is validated, and the result that can be just true or false, like exist a path where happen first this apply screw anchor and then the finish plastering activities. So as soon as our model is correct, we can, as said, being simulated like previously. This is the interface of the simulation that take also as input the model and the simulation parameter, and then be sent to the execution engine for execution. So here we can see that the workflow is deployed and sent to the i3D system for refinement into workflow and execution. And in the next part that I think sorry, this is the last part, but okay. Basically, as soon as the process is executed, the component allows also to visualize the status of the process in form of KPIs. So we have the KPI that we defined in the previous model are used to generate this kind of dashboard that visualize the status of each activity with the also with that sort of trustability indicator for each KPI. For example, we can see that for KPI based on the simulation, the reliability of this KPI is not 100%, but for KPI measured directly, like reported by the execution system, this reliability is 100% because it's measured and reported by the user. And this view can be also customized and contain, for example, all the result of the previously defined KPIs in the KPI models. We can see in this part also the effective services generated. So I previously showed the model that are used to create the services used by the automatic task of the activity and by the KPI retrieval. And these services are actually, or to say, this model are actually used in this platform, this microservice controller, in order to actually have to generate automatically the effective REST service. So we can have REST service, as we have seen, for retrieving the scenario from the before, for retrieving the KPI values from the execution engine. In this case, what we are seeing now is the service with the all parameters, so the post endpoint, the post input, and the JSON output that are resulting from the BIMERR interoperability framework platform about the scenarios available for these renovations. We have a lot of services in this case. Like I think we can skip this part, but in this case, for example, this is the service used for retrieve the simulation part, but I think this is the last one. And I think it's missing the video from the execution. Sorry, or we skip too much?
Yes, I'm sorry, this is probably my fault because I was
Yes.
not able to process the oh, okay. The video
No,
is
it's
there.
fine, it's fine. I can present, or Martin, please feel free if you want to.
Okay, you can maybe play the video and I can narrate it.
Yes, I think from here.
Okay, so right now, right here, you can see the PWM for workers. We are importing the process model created in the PWM modeling tool. And after importing it, we can create the workflow, which is sort of a bone structure for the work. From the workflow, we can later create multiple work orders, one or multiple. But each workflow has to be first approved before being used as a base for the work orders. Until it is approved, it is saved as a draft. And each approval only lasts a limited time in which you can set the duration by yourself. Once the workflow is approved, you can create a work order from it. And as I said, you can create one work order from one workflow and have it this way, or you can, in case of duplicity or reusability, you can reuse the same workflow multiple times and multiple work orders. For example, if there is one type of work that needs to be done across multiple floors or multiple rooms, you can this way reuse the one same workflow. Next, you specify the building and the space in which the work order takes place, because this work order is a specific work action that needs to be done. You specify the worker that is going to be responsible for the work. And in case if there are multiple lanes of work, for example, the lane of the lane for monitoring, the lane for the worker, and I don't know, the lane for testing, for example, or checking, you can specify which workers will be responsible for which lanes. After setting the time of the start and the end of the work order, you are basically ready to save the work order, and the appropriate workers are notified about the creation. After that, you are free. If the workflow that you important contained any sort of automatic information, for example, emails and information that need to be added later, you are free to input this information right now. And you can also see the process model, I mean the diagram of the process model that is being used as this work order. You can click on specific actions and you can set the planned start and planned end. You can create health and safety issues for each of the tasks. And if needed, you can also set the location of the task and the current provider if needed, because the main provider that is responsible for the whole work order does not need to be the same as the one responsible for certain task. So as you can see right now, this is the creation of the health and safety issue. After we choose the location and the text of notification, we can choose the type of the notification. For example, in this case, we created the text increase levels of dust and noise. And we can select the notification warning that it will occur 1 hour before the beginning, and the type of notification, noise and dust. This health and safety notification will be sent to the residents by the PWM for residents. And right here you can see the PWM for workers, so the application that is running on the smart glasses or in the smart device. After logging in, you can select the work order that you want to work on as a worker. You can see all the work orders that are assigned to you and are not completed yet. You can see the actual information and details, and you can start the work order. While working on it, you can see the camera feed from the glasses or device. You can take multimedia, you can take photo, record video, or record audio. You can call your colleagues or foremen or managers through the remote assistants if they're available. And you are basically free to do the work that you are assigned to do. After that, you can create a work order result or a task result, I'm sorry. So you end the task by providing some sort of text. You can see the multimedia that you created in the work order, and you will select if it's a success, problem, or an error. After doing so, you are presented with another task, and this goes basically until the work order is completed. So let's say that there is a problem that needs to be resolved. You can report it directly as a task result, and then you can finish or end the work order not with a state of completed, but with state of aborted, for example. And right now, when we go back to the PWMA for managers, let's say that that the worker has just completed the work order. We can see it in the list of the work orders. We can click on the flow diagram and see what specific tasks have been completed without the problem. We can see the results text and the time of running and the completion, and we can also see the problem that was logged. We can generate a printable work order report, which informs us about all the information that we wish to know, for example, the actual duration of the work. We can see all the tasks with their results and captured multimedia, and we can also see all the notifications that were created during the lifespan of the work order. You can also see the notifications that you received as a manager if you click on the notification icon, or you can alternatively log into the notification system itself and check all your notifications right here. Basically, the users are mainly notified about creation and completion of the work order, and also the managers are notified if any worker is starting the work order execution, so they are up to date. That is all.
Right. The next tool, yes, the next tool in the process is the PWMA for residents, and here we can see that the user can select the language. First of all, it's a multilingual application since we had pilot sites in Poland and Spain and Greece. Afterwards, the resident logs into the application with credentials that were provided during the registration process. And this is individually tailored so that each resident gets information that regard only the area around where they live and not areas in the building that do not affect them. So here they can see in this screen, the first tab, all the tasks involved in their area. They can select the task and get some more information about it regarding the time it starts, the time it ends, and they can also provide a comment regarding this task. Here we can see that the user will write a comment regarding the delay of this task, where it was supposed to start earlier and hasn't been started yet. So from the top right, they can change the way that they view this list from individual tasks to a calendar view. So they can see specific dates, what tasks are involved. Here you can see that for the date of February the 22nd, a number of tasks have been scheduled, and they can check each one of them and see small information below. Now, they can also, the residents through this application provide issue reporting, as we said earlier. So in this tab, they select the building, the apartment they want to report the issue for. And they can select the type of report they want to submit. For example, health and safety, malfunction, maintenance, or functional suggestion, or any other topic. And in the next screen, they can add the title of the issue, electricity cut, for example. And then in the description, a bit more details about what the issue involves. Now here it's not very informative. What you will see in the video, there is an electricity cut. And then after the description is added, they can also attach photographs and videos and audio recordings as well. Here we can see an example in the video. So the user can select the video camera from the screen, the phone, and go around and capture a video or a photograph and assign it to this particular issue report. First of all, this was a photograph, and then we will see an audio recording as well. I cannot hear actually what the user is saying right now because the video is without sound, but they can also attach an audio recording. Finally, in this third tab, the user can check any notifications that have been sent by the manager to the residents regarding health and safety issues that may occur during the tasks. And they can also manage these notifications in the settings by turning them on or off and when to receive them. So, for example, only when the task is to start, but not after the task has been finished. And all the issue reporting that the user has conducted is stored in a list by all the issues here. They can check what they have sent to the manager. And finally, there's a screen in the application where the user can learn more information about the project. Thank you.
Thank you, Thanos. So, having watched the entire demo video, now I don't know at this point if there are any questions regarding this, the PWMA toolkit that was presented. I suppose no. In that case, we can proceed to the final tool, the BIMERR interoperability framework. So, Nefeli, thank you. The floor is yours.
Hello, Ari. Hello, everyone. I hope you can hear me loud and clear. Together we'll see the BIMERR interoperability framework, BIF in short. That is a cloud-based platform developed by Suite 5 and Ubitech and acts as the main data exchange facilitator in the BIMERR project. And this is why it is not part of a specific phase, but it spans over the phases of the renovation as a horizontal tool. Next slide, please. Okay, so as we said, it is the central point of data collection and exchange among the BIMERR applications, tools, and users. And it facilitates semantic interoperability through the underlying common data models that can be used by the users in order to appropriately attach a meaning to their data and make them available to other users in a way that they will be commonly understandable. So the main functionalities offered by the BIF are first flexible data collection methods that can be used by the authorized BIMERR users and tools. Then we have the underlying common data models that can be managed throughout their entire life cycle through the data model management. And we also have mechanisms for the findability and retrievability of these data that are available in the platform by other tools and applications. Next slide, please. So after using the BIMERR interoperability framework in the validation and pre-validation activities of BIMERR, we have seen that BIMERR applications and BIMERR compliant applications are able to exchange data and that any emerging data or feature needs can be covered by extending the available functionalities, as also pointed out by Serth regarding some needs of PWMA and ARIPFA for the uploading of data as attachments to actual data. And also we have seen throughout this process how important the extensibility and the continuous adaptation of the available data models is in order to facilitate emerging data needs that have not been foreseen from the beginning. So these are the two things that we have learned, that a lot of data modeling job is required in order to facilitate the data exchanges among the existing tools, but also in order to be extendable and applicable to future additional users that want to use the BIF. So just to demonstrate these functionalities and give you a better idea, in this video, we will see three main flows. The three main flows of BIF. So first, the user will upload data. Aris, please pause the demo for a while. Thank you. So in the first flow, we will see how a user can upload data to the BIF and configure the uploading process. In the second flow that is intertwined in the first one, we will see how a data model can be adapted, extended, and modified in a dynamic manner through the data model management page, and how this is done in a backwards compatible way in order to not affect the existing data. And in the third flow, we will see how the data that have been uploaded in BIF can be retrieved by other eligible users. So please, Aris, unpause. Okay, so here we will see the first flow. Here the user is creating what we call a data check-in job. So it is a configuration of how she wants to upload her data with which one of the harvesting mechanisms available through BIF, and where she will also configure how this data will be translated according to the underlying common data models. So here, after first creating data collection job, the user can choose among the three methods: file upload, data providers available API, where, for example, an external API is exposed by the user's application, and the BIF will make requests there, or the platform's API, where the BIF provides customizable APIs for the users where they can post their data. So in the harvester configuration of the platform API, the user can either upload only data, only text, or text and binary, as in this case, where a file is going to be attached and will not be further processed and mapped to the underlying common data models, but will be available to consuming applications as an object. So after also selecting a sample that will be the base of the mapping configuration that will be performed in the next step, the user can see that an endpoint, a URL, has been created. It has been created only for this job by the BIF, and she can later use this in order to upload data. Here we have a sample preview of the file, of the JSON file that the user has uploaded, and you see that in the end, a field has been added to the data, that is the underscore uploaded file, in order that will act as the attachment. So in the second step of the mapping, we see the available domains. Already we have models covering occupancy, renovation process, KPIs, and other data modeling needs of the BIMERR applications that we have seen in the previous presentations. And after selecting the building domains, you can also select the main base category that will be used for the mapping. In this case, we have building data, so the building base category has been chosen. Here you see that already mapping has been performed. This is a prediction that happened under the hood and is based on string matching, name matching, etc. And the user can, of course, go there and correct any wrong, any inaccurate mappings that have been predicted. She can also add some mapping details to the predicted to the mappings. So in order to facilitate the transformation of the incoming data to the correct format in the BIF. For example, for Aris, could you please pause the video for a while? Okay, so these transformations, they are unit transformations. They can be also additional information like the order if we're talking about arrays. So in order to support all the different incoming data, we provide a lot of customizable options to the user in order to define how their data are, in which format they enter the BIF, and then transform in the common format. Okay, thank you. So here, the uploaded file is the added field that was not existing in the original sampling, has been added by the BIF because of the binary attachment that is also going to be sent by the user. It needs to be mapped to a binary type target field, and in order to be actually included in the resulting data asset, as we call the result of a data collection job. So here the user continues by adding, as we said previously, some additional information to fields that are required, like measurement unit. In these tabs, the user can see any invalid mappings, and she continues by trying to perform a mapping of the project identifier field. So here you see that we already have on the left side a related project high-level concept. However, we will try the scenario of suggesting a new field in order to showcase how the model management works. So here the user, that is the data provider in this case, says that she's missing a new model concept, the project identifier. She would like it to be directly under the building parent concept. She provides the data type, a description, and then also provides some related terms that are used in the mapping predictions. So after submitting this request for the new model, as you can see a success toaster image, toaster message on the downside. And let's say that now we have a user that is also a model manager, but it is not always the case. The users are not model managers, but in this case, we have a model manager user that has access to the model management page, where she can see all the available data models created in the BIMERR project. She can go to the building data model, where she can navigate through the concepts, the high-level concepts on the left side. So you can see the concept details and all the fields that are included under each concept on the central panel. So here you see we have found an indicative example of a field, we can see that it has some metadata that are also working in order to define if a field is going to be used to denote spatial characteristics or temporal characteristics of the asset. And here you see that the user has gone inside the building high-level concept, has found the proposed field, the project identifier. She can perform some further edits on the field. And finally, she can either reject or approve the proposal. In this case, she will approve the proposal. And after approving the proposal, the field is added to the data model, as you can see in the fields panel, and the version of the specific data model has been changed from 1.11 to 1.12, as it is a minor change, in order to denote that something has changed in the underlying system and facilitate this backwards compatibility and the identification of this change also in any ongoing configurations. So going back to the mapping that we were performing earlier, the user can find will search for this new field. As you see, it now appears on the left side. She can take it and use it in the mapping. Okay. So after saving this mapping, we will see how the reverse action would be like in BIF. So let's say that we want to remove a concept or a field. So going back to the model management and to the building, there might be the case that, for example, some fields have been deprecated because it is also these models have been created based on standards. Maybe in order to be aligned with the new standards, some existing fields should become obsolete and replaced by new ones. So in this case, you see that we go to the field that was added in the previous step, and we choose to deprecate it. After deprecating the field, it is now, as you see, appropriately labeled and is no longer editable and no longer part of the active fields. The user that is concurrently performing a mapping configuration will receive an appropriate warning that notifies her that a field, the specific field, has been deprecated in the latest version of the model. So as you see, it is not broken, the mapping configuration that was already performed, and the user is appropriately informed in order to correct her mapping and configuration according to the latest version. Okay, so after using a nested mapping now, the related concept, related project, and then using the identifier field, the user can proceed with the mapping report. She can view her selections. It is, we should note here that only data fields that have been mapped will be kept in the resulting data asset. And it might be the case that, for example, an application sends to the BIF various fields, but they are not all destined to be part of the asset. So here it is the final step of the configuration. The user can provide a name and description for the resulting dataset. And we see that the data collection job has been labeled as idle harvesting because the actual data have been sent yet to the provided API. So here we will see how the user can use the provided URL in order to make a post request to the BIF. And this is a way that also applications use on their backend in order to send their data to the BIF directly. So it is not something that needs manual intervention. In the instructions, the user can see that in order to send text and binary files, it needs to create a multi-part request where she will use two key value pairs, the underscore uploaded underscore file key with a value, the attachment that she wants to send, and the data key where she should input as value the actual data that she wants to send to the BIF in JSON format. Here we should note here that this data that will be sent to the BIF, they should comply to the structure of the sample. So it should be formatted in exact the same way, but of course the values can vary. So here we have taken the sample. We're changing some of the values just for the demonstration. And we will proceed. We are removing the uploaded file field because, as we said, this is something that is going to be automatically created by the BIF, added using the uploaded file. And finally, in order to authenticate the user prior to making the request, she needs to also provide an XAPI token in her request. This token needs to have upload rights, and this way the user is authorized to perform the specific request. So after pasting the token that has been provided through the BIF, through the relevant model in BIF, the user can send her post request, and after waiting some seconds, we see that we get a 201 created success response. So in the meantime, under the hood, the relevant data collection job has been activated and it is processing the received data. And the user here begins to configure the metadata of the created dataset in order to make it easily findable and available to other users of the BIF platform. So here we see that she can set values to the available metadata fields. If you noted, there are also the status version and category metadata fields that have been added according to the ISO 19650 in order to be aligned also with this standard. And the user continues in the meantime adding some information regarding the spatial coverage, so which area is covered by the data that are uploaded, the temporal coverage, which period this data are relevant to, and finally she can create access policies that will regulate who user or application will have access to this data, both in the search page, but also who will be eligible to make requests and receive them. So these access policies are attribute based, so they can be based on the username, on the related group, or based on the application. And it should be noted that here the available values in the dropdown are taken from the key clock groups. So after creating also the access policies she wants, can you hear me?
Yes.
Yes.
Okay, I think it was frozen, the video. Aris, a bit forward.
It's a bit more, yeah, it froze, the video froze completely. Yeah, there's an issue here. I don't know.
For me, it's running, actually.
Yes, this is where it froze, I think, during the metadata.
Is it? Can you see it? Does it run for you smoothly
Yes.
now?
Yes. Up to the access levels, we were okay also previously. So yeah, something that I did not describe was also that the user can attach licensing information to the data. So who is the copyright owner? If she wants to attach a specific license, apart from the access policies that will be enforced during search and retrieval time. So here the drop down, as we said, it takes values from the key clock, and I think this was where it froze also in the first iteration. Aris, could we go to 15? Yes.
Unfortunately, I don't know what the issue is. I can share the screen with a video outside the presentation. Give me just 1 second. I'll fix this.
Okay.
In the meanwhile, we can ask if there is any questions on Natalie.
So, can you see the video now?
Yeah, yeah.
Yes.
Can you
Yeah.
move it to minute 15, I think?
Yes, to 15. Okay, okay, perfect. Thank you.
Thank you. Sorry for that.
That's fine. Okay, so after saving the metadata, the user can view the dataset, including the license details, the access policies that have been defined, and the structure of the data. So you see here that the data collection job has been completed. It has the green ticks in all 3 steps, and we can see the reports of each step. Aris, I think it is it on fast forward? Or is it in normal speed? Okay. So here we see how the users can consume the data that are available in BIF. So they can enter the search page where they can use the available filters on the left side. They can also perform some text-based search queries in order to identify the available assets under its domain, for example, or a specific asset if they already know its name, as in this case. So after identifying the asset that we want to retrieve, the user can view the accompanying metadata and accompanying information, and can enter the profile of the asset in order to have a high-level view prior to retrieving it. And finally, she can use it in order to create a query. So the user already has a list of saved queries that maybe already that are maybe already used by her applications in order to retrieve data. So in this case, the user will create a new one. She can select the asset. She must enter a title and description for her query. And in the second page, she can have an overview of the dataset, the structure, where she can select if she wants to get all the available fields or just a subset of them. So after, in order to also retrieve the attachment, she must make sure that she includes this last binary file that is in the end of the list. And Aris, now I think that is a bit too slow, the video. Okay, thank you. And she can also use these fields in order to filter the response that she gets from her request. So here she will use the project identifier in order to retrieve back only building data that are relevant to the specific project ID. And this is a very useful feature in cases where we have data from multiple apartments, for example, or from multiple users. The user can search inside the data and filter the request through an ID. So in the end of this configuration, the user is again provided with a customized endpoint that she can use either to make a GET or a POST request from where she will retrieve the data. So back to the Insomnia here, to the API environment, the user pastes the provided API. She must change the parameter, the related project identifier parameter to a correct value in order to retrieve actual data. Otherwise, she will get back an empty response. And she must also be authorized in order to get data. So she will generate an access token that will have a retrieval scope in the BIF, and she can use that as an XAPI token header in order to be authorized. And this is a way to ensure that any data exchanges happen in a secure manner and only legitimate users have access to data. And as you see, the request has been performed. The user gets back the data, that's the specific fields that she selected to get back. And you also see that the file has been is available as a URL again, where she can make a second GET request in order to also view its contents. And this is the next step of this video. So the user uses this URL. She can use the same XAPI token, so a user can reuse their XAPI tokens for their data collection jobs and their own queries. So they are bound to a user and not to a specific query. And in the Insomnia, you saw how she got back the IFC file that she had attached. That's all from my side. Thank you. And if you have any questions, they're welcome.
Thank you, Nefeli. And I don't know what happened there with the video. It's I apologize for that.
No problem, no problem. I had more time in order to explain some things that were not shown in the video. So.
Aris, you will continue the presentation, or should I share my screen for the best practices?
Actually, I can share the screen. Just yeah, give me 1 second.
Okay, so based on the feedback we have got through the pre-validation and the validation of the project with actual users, we have derived some best practice advice and examples of BIMERR use. And the topics in the best practices we have extracted from that, we're based firstly on the deployment optimization. So for the wireless sensor network and the AR market deployment in the sites where BIMERR is to be used. So for the wireless sensor network, some of the recommendations to overcome some of the issues we encountered were, first of all, to have timely battery maintenance, so not forget to change the batteries, to minimize the occupants' disturbance, so lights and noise that some of these sensors may incur. For example, these blue lights of one router disturb one resident, the thermostat on the right made a sound opening and closing the valve that were annoying to the user, things like that. Moving on, Aris. So some aesthetical interventions should be avoided. For example, not leaving things hanging from the walls, but mount them in a way so that they minimize the effects on the users, the residents' aesthetics. So to avoid some of the pitfalls from the sensors themselves, some of the software involved in some of the providers of the sensors had bugs. So we needed to fix them and be in direct contact with the providers themselves. You can see here some devices were offline for a long time. So we had to contact BIMERR directly in order to change some of the parameters. Moving on. Regarding the augmented reality installations, as I said, we needed to place some image targets, we call markers, in specific places of the building. So after a few issues we had with that, we devised a few guidelines on where to put them and how visible they should be and how lighted the area should be. Next. So regarding the tool use in the validation sites, we talked about some of the lessons learned in the previous slides. So we will just cover some generic tips and tricks for that. These are basically more involved around the augmented reality technology tools, namely the PWMA for Workers application for augmented reality and ARITFA. Can you go next, Aris? Yeah, basically, for users that have not seen or used augmented reality before, there is a process to familiarize them with augmented reality and how to use the devices themselves before even going into using the BIMERR tools. So how to stream data from, so make them see what is the result of what they will see using streaming. Here is an example on the right. An experienced user is wearing the helmet and the inexperienced one can see on the laptop what the other one is doing. So this is a good best practice idea. Some safety considerations. First of all, to accommodate them in an empty room first so they can understand how to move around while wearing the device, and then move them into the actual area they will use it. To provide easy installation instructions and video tutorials, etc. Moving on. Regarding the input data gathering during the project, here are some of the best practices we gathered. So regarding, for example, the model generation and the IFC creation, we extracted some guidelines. First of all, regarding the BIM authoring tools, and namely Revit, on how to properly gather the information, for example, dimensions, materials, thermal properties, and how to input them into the tools. And, for example, how to insert any components into Revit, how to define spaces and zones. how to generate Revit families, custom Revit families for some of the components, and then how all this ties into the interaction with the BIM management platform. For example, how to perform the geometric error detection and the thermal properties enrichment. And finally, the best way to export IFC files from Revit tools, from external tools. Next slide, please. Now, this was all gathered into some guidelines we have published, and also there's also some guidelines we extracted regarding how to perform a laser scan correctly and what to look for, and how to plan and execute the laser scanning survey, and how to pre-process the data in order to ensure that the clouds produced are of high quality and they will not produce errors like Fred showcased in the scan-to-BIM tool. Next slide. Now, regarding the energy efficiency data gathering, so namely how to use the sensors placed in the apartments. Some details about the environmental product declaration were extracted. The life cycle assessment and life cycle cost of the related products of the building were looked very closely. So basically, this involves, give me 1 second, how to the necessary energy efficiency information is collected is necessary in order to be used for generating the renovation scenarios. So if we start with good data and properly pre-processed data, we can extract better renovation scenarios. And based on that, we devise some guidelines on how the static data is defined to be captured within an IFC file. So some naming conventions, for example, how to name certain property sets, the connection, for example, of the HVAC systems and basically the producers and consumers in circuits. Regarding the dynamic data, how the set of rules is applied to properly populate instances of the necessary of the XML classes and things like that. Next slide, please. Now, regarding the maximization of energy savings, some guidelines that we defined during the project, for example, was the efficient preparation of the BIM model in order to maximize the savings, to create reliable estimates of the building energy demand using Energy Plus, in order to reduce the gap between the simulated and measured estimations of the building performance. You need to have consistent, complete, and correct IFC files, and generate the Energy Plus input data file correctly based on the IFC file. And then finally, to perform the building energy simulation, and it's with data concerning the occupant behavior profiles. So using both the collected IoT dynamic data and some data provided by the big application from the users themselves. This can all be used in order to maximize the potential of the BIMERR tools with regards to the renovation. Finally, regarding the applicability and the replicability of our results to other countries. First of all, the weather data we are using within the tools is available for 34 European countries. So apart from Greece, Poland, and Spain that we performed our tests and pilots, the same can be performed in all other European countries through Energy Plus. The building and material database we have created through the project contains materials that were originated from Austria, Germany, and United States, but they are generic enough so that they can be applied with very slight modification in Greece, Spain, and Poland through the pilots. So they could also be applied into other European countries with minimal modification. So basically, this is a blueprint for integrating further with different national building material databases. We go on from that. Now, the standards we have followed were diverse. So basically, we followed both international and EU BIM standards and ISO series in particular. You can see here in the diagram some of the standards that we used, and basically we are up until here into the ISO 19650, which was used for the process modeling. And following from that, Harry? Yes, and some generic, best practices. Since we are going to be deploying in different countries, all applications should follow multilingual and multi-currency support, which is applied in both RenoDSS and the PWMA for residents. And you can see an example of the multilingual support in RIFA and PWMA for residents. And I think this concludes, yes, the presentation. If you have any questions regarding this section or in general the entire presentation, I think we have a section here for 10 minutes where we can discuss. And I give the floor to you, Aris.